Welcome to all. I am very happy to meet you. You have decided to appear for NTSE examination, and I have assigned the work of giving you some tips and some information about chemistry. Before starting this lecture, I must tell something about myself and why I accepted this particular invitation. I am Dr. Ranade retired from Vachan Engineering College, Sangli in 2003. Now I am running 77. So when I was of your age, maybe before 60 or 65 years, I was all the time dreaming to be a chemist. I wanted chemistry to be my profession, and that is why I selected the topic of chemistry. Afterwards, due to competition of other students, and I was swayed away and I joined the engineering. But still, fortunately, I could get environmental engineering branch, which deals more with the chemistry. So chemistry, biology, physics, all these sciences are combined in environmental engineering. So I had opportunity to remain in touch with this chemistry, and that is why I accepted this. Maybe my knowledge may not be so correct, and maybe there may be some mistakes, but you are all clever. You have been studying in the 9th and 10th. You know already everything. What I can tell you is what is more important to remember, and what examples and what problems may be coming for the examination. You have been studying this particular subject in detail. I did not give you more information about that, but I promise you that whatever is the textual information or academic information, I shall be sharing with you through our website webvinyan.net. So I request all of you to give your contacts to me on info@nandeep.net, and once you do that, we can start our work. Now, next please. The background that this NTS course was started in Savarkar, Pratisthan, and initially the founder, late Shri Namdoshi sir, GP Kantak sir, my younger brother Srikant Ranade took efforts in starting this course, and they gave the lectures, and so many students passed this particular examination, and they went even to national level. So I had opportunity to again come back to you for this particular session. I congratulate Shri Sunil Deshpande of Vachan College to take the initiative and arrange this particular session even in the Corona lockdown conditions. So let us start with our work. Next. Now the chemistry. Chemistry is a part of science. Now what is science? Science is, we are studying the rules of nature. We try to understand how the nature is constructed. The intelligence, human mind, earlier was mainly thinking of religion. They were believing everything. And then through intelligence, then they started thinking, let me find out the reasons for that. So the reason for the nature was found, and the science was developed. And in the science, the physical rules were explained in physics. Chemistry gave the reactions, chemical reactions, which we will be dealing now. And the last is biology. Biology is a life science. It is the most, we generally intelligent people don't like biology. They say it is all just some bodies and these things. But that is also a very important branch. Now you have understood due to corona and suddenly medical field has become big. So everybody wants to go from engineering to biology also. So biology is a life science, and that life science also requires chemistry, physics, everything. But the chemistry there is entirely different. The chemistry there has got so many restrictions of temperature, of pressure, of acidity and other things. And that is why the chemistry there is a different branch than our normal chemistry. When I was studying in the post-graduation, there was a chemistry subject, and when we wanted to study, our chemistry professor said that what you are doing, whatever chemistry you are doing, you don't know the chemistry. But then we told them that we are using the chemistry only of life, living matter, and living matter cannot accept extreme conditions of pH, extreme conditions of temperature, extreme conditions of oxygen pressure, anything. All those things are not there. Those things are there outside the earth, but earth has got life, and there this chemistry is specifically life chemistry. So in the next lecture, tomorrow's lecture, we shall be digging more about that organic chemistry. But initially now we will be studying about the chemical reactions and what they are done. So next plot. Now materials in nature. You can see that nature is composed of inorganic and organic materials. Inorganic materials you can see either as a gaseous or as a liquid or solid. That means air, water and soil. That may be containing rocks and other things, even magma also you can consider. So this is the physical description. But if you want to find out chemical point, then air will be a mixture of gases like oxygen and nitrogen mainly, and some other trace gases are there. Then water, that is H2O, and soil, that is minerals. So many minerals are there. They contain all metals, non-metals, and either they can be mixture or there can be crystalline. Everything is mixed there. But that is in a solid state. Solid state, liquid state, and gaseous state. Fortunately, water can form all the three states. That is ice, water, and vapor. All the three states it can do. So water is taken as a very important element for the life formation. And there is another thing which is very exceptional on earth, that is CO2, carbon dioxide. You know carbon dioxide, it has got double bonds, 2O and joined to C. So it has got 4 electrons in the outer circuit. So those 2 electrons are taken from oxygen, one oxygen, another oxygen. So 2 double bonds are formed, and that CO is formed. And fortunately for us, this CO2 is gaseous stage. So it remains in the air. So it has got a very good combination with the water vapor also. So this has caused the life to germinate. Then the scientists started thinking, is there any other element that also can replace carbon? They found SiO2. What is SiO2? Silicon dioxide. That silicon dioxide is sand. We have got plenty of sand. So SiO2, can SiO2 replace CO2? No, because SiO2 is solid. It is remaining there. It doesn't come in contact with water. This HCO2, CO2 and H2O, they come together, they marry and they start building the carbon compounds, and slowly the life got explained. This is the beginning of the chemistry. Next please. Organic and inorganic, that I have given the explanation. Then inorganic compounds are there. Those inorganic compounds are that way do not have any relation with the other materials. They require extreme, some conditions, pressure to interact with each other. So the chemical reactions that we do in engineering, like say foundry, or we extract some metals, there we use the chemistry. That chemistry deals with heating the substance to a very high temperature or doing some such things and adding sulfuric acid, hydrochloric acid, very strong acids and like that. All those things come under the inorganic chemistry. Organic chemistry is dealt with also these things. Of course, organic chemistry also has been now advanced, and people were thinking that organic means whatever is derived from organ is organic. But then plastic was generated. The plastic is all carbon compound only. So man has developed compounds based on that organic chemistry, and it has created so many chemicals and some compounds which are organic in nature but do not come from the light. They do not come from the light. They do not come from the light, but still they are carbon. So they are saying compounds are organic. They are saying. So this is the difference between organic and inorganic. Next, please. Now Avogadro's number. Have you heard Avogadro's number?
ते तुम्ही झालं सर कोण आलं माहिती
Avogadro's number. Avogadro, the scientist, has converted atomic weight to directly our measurable mass, that is grams. What he has decided? That atom may be having very small weight, you cannot measure also. But if you can find that how much, whatever is its atomic weight, that atomic weight will be containing, one atomic weight will be containing a particular number of atoms actually. So if we take 1 gram of a substance, then it will contain so many atoms. Suppose we take hydrogen. Hydrogen has atomic weight of 1. That means if you consider 1 gram of hydrogen, it will contain 10 raised to 23 atoms of hydrogen. And he found that for all molecules, all atoms, all ions, all radicals, the same rule applies. That means you can consider 1 hydrogen atom and say 1 nitrogen atom, 1 oxygen atom, any other atom, we can consider, we can find the number and we can then compare one with another. It is like comparing ant with elephant. The ant is there very small edge and there may be PB lead which is having very heavy, but still we can say if gram moles are considered, that means if 1 molecular weight or 1 gram atomic weight is taken of these two things, they will be containing exactly same number of atoms, either of hydrogen or of lead. And this particular derivation or this particular rule paved the way of all chemical reactions. Now we can combine the chemicals together and just think of atoms or molecules what are operating there. So we could calculate how much will be the product from the reactants. So this is the basis of chemical reactions. Next please. Next. Now molar and normal solutions. What is molar solution? You know, 1 molecular weight dissolved in 1 liter of water means not 1 liter of water, 1 liter of solution. That means after adding the volume should be 1 liter. Then it is called as 1 molar solution. That means 1 molar solution will 10 raised to 23 moles of that particular substance that we can consider. So this is molar solution. But we are doing it sometimes without doing a proper method. What do? We take 1 liter of water and add 1 molecular weight. When we add 1 molecular weight of a substance in the 1 liter, the volume slightly changes. And then it will not be the molar solution. It will be called as molar solution. M-O-L-A-L. Molar solution. So molar solution and molar solution, we use only molar solutions. So molar solution, once whatever are soluble compounds, we make them soluble and then start reactions. Molar solution. But instead of molar solution also, then people thought that not all molecules will react as it is in the life and other salts and other there, acid, salts, etc. Next please. So the molecules, how the molecules are formed? The molecules are formed because there are some electrons on the outer shell and they are unstable if the entire shell is not filled. If it is not filled, they will try to take help of another nearby atom or molecule to fulfill its demand so that it will be stable. So, oxygen has got say 4. So, 2 oxygen he has got extra. So, they will combine together and form O2. CO2 has got 4. C has got 4 electrons. So, oxygen's 2 electron, another oxygen's 2 electron, those 4 electrons, they will combine together, they will have covalent bond. Covalent bond means they share the thing with each other. Just as suppose in an apartment, so many people are living and there is only one latrine and one washing house, bathroom. So we all share that. So everybody will live comfortably. Same way, those electrons will form a group and they will meet the needs of all the other nucleus. So that covalent bond is. So covalent bond is a very strong bond. There is another ionic bond. Ionic bond is that where the electron is directly transferred to another thing. That means the girl marries and goes to another family. So NaCl, Na gives its electron to Cl, but still they live together. NaCl. So this is ionic bond. Everybody is separate, but still they live together. NaCl. But as soon as they go in water, they separate. Na will be separate, Cl will be separate. They will be roaming around and they will be having friendship with other ions also. And at that time, water comes into picture. This water has got the third type of bond that is known as hydrogen bond. This water, H2O, that is O, is connected with 2H. H has got 1 electron. Another has H has 1 electron. And this particular oxygen has got 6, it requires 2. So it joins with the 2 and it becomes H2O. Now H2O, when it forms, this H, they are sharing. But they are even if they are sharing, when you share, naturally you lose something. You have to sacrifice something for that. So what happens? Even if H is sharing its electron with O, it finds it has got some love with the electrons. He finds friendship with other electrons anywhere. So he is slightly positive. Delta. And oxygen also, even if it is taking these electrons here, so it has got extra, its own, it is more than taking. So it is like a magnet. When it is magnet, you know the magnet, they will be either joining together or repelling each other. So what happens in the water? This particular water molecule will try to, this H will try to have friendship with O of another, and O will have a friendship with H another.
आवाज बंद कर
मला आवाज कर.
Like this, the water, this particular molecule gets adjusted with each other and they have bond. Now when the ionic bond is there, NaCl or any other chemical, when it goes inside and it splits into two parts, you might be knowing electrolyte. Electrolyte means all the salts which can be dissolved in water and still split in the form. What are the electrolytes? Acids, alkalis and salts. So acid, base and salt, these three are there, they are called as electrolytes. And the electrolytes, those who have lost the electron are called as cations. And those who have got the electrons are called as anions. So we must see that any dissolved salt or acid or anything will never exist in the water as a complete molecule. It will always be present as either cation or anion. They will be separate. They will be free to move everywhere. But when they are separate, they are again surrounded by this polar molecule. So every cation gets hydrated due to water molecule. Even though water is neutral, still